Hi friends, welcome back. In the previous session we have seen the simplest cryptographic method, that is a simple substitution cipher method, wherein each character of the 26 in the alphabet are replaced by another character. The simplest one is just substituting a character some n distance away in the alphabet set, or even we can have the combination of all the 26 characters. So with that we would get 26 factorial, that is something like 2 to the power 88 combinations possible. To identify the correct combination, it is almost impossible, because even if we try to work with the best possible computer that can solve 2 to the power 40 combinations in 1 second, then also it would require somewhere around 9 million years to check out all possible 26 factorial combinations. So that's a brute force method, which is not a logical one. But yes, of course there are some other ways to solve. If we use the knowledge about the language, we can just try to find out in some way, applying our knowledge, applying the information we have about the language, we can somehow crack the code easily, not in terms of millions of years, but in terms of minutes or hours. We could solve the problem if it is a simple substitution method. So let's see what is it. So let's take an example that's been substituted using some combination. So some English text is encoded, and what we have is this here. Now the question is how to get that this first character P, it may be A, it may be B, it may be C, it may be D, and so on. So there are 26 possibilities for replacement of P, and same way for B there will be 26 replacements, and so on. So it's if we just look at the brute force logic, then it is almost impossible. But yes, there is some other way. We just look at the properties of the English language which we are using here. Then it says that there are some characters having specific frequencies of occurrence and all that. So if we look at the English alphabet and just take up any big text, any book, any big volume, then count each character, how many times it is repeated, then we realize that more than 12% of the characters are E. That means E is most commonly found character in any English text, and then it is T, and then it is A, and so on. So that's the graph is showing, the bar graph is showing the probability of occurrence of each of these characters. Yeah, that's what it says. Then let us see what the probability, the frequency of occurrence of the text we have with us, the encrypted text. That is, the first line is shown here, PB, FP, VY, and so on. So if we count the characters in these, then we see what the frequency is, and that's how the frequency distribution is for this encrypted text. And we find that in this highest probability is with the character F. So somewhere if we try to correlate this and the original one, then it says that in English the highest probable character used is E, and in our encrypted text the highest character used is F. So that means in some way, if we can think that F may be replacing E while encrypting, if we take that, then the third character here is F. So the other what you can say, the common sense or the knowledge what we have about the language, most of the sentences in English start with say the THE, and in this case the third character happens to be F, and F appears to be the most commonly occurring character in the encrypted version, which may be equivalent to E. So if we assume that F may be representing E, then we can just look back and we see that there are other two, P and V. So P may be talking about T and V may be talking about H, and we just try to compare that. So this is about E and F, okay. Then what we want is T with P. So here P talks about somewhere half of F, whereas here T is almost 1/3 of E, so they are somewhat maybe matching. And if you look at B and H, the B is somewhere again half of F, and H is almost half of E. So if we just try to correlate that, we may feel that P may be T, B may be H, F may be E, then the first word is THE, then the second word starts again with T, then so that way if we just look at, if we say P is T, B is H, and F is E, and we substitute them, then some of them are available. Then looking at the neighboring, we can try to predict. So like we have 2x here, xx, so that means there should be double characters. So double characters, what all are possible? It may be double E, it may be double O, it may be double L, it may be double D, it may be double S, and so on. So there are limited number of characters out of 26 which occur in pair in adjacent positions. So that type of logic if we can apply, then we could easily identify the key, what character is replacing which one. So how the encryption key is and all that we can identify with knowledge about the frequency of the characters usage, knowledge about the words, knowledge about the word followed by what word, and what word follows which word and all that. So I am going to school, if it is there, that I is there, then am is there, then going is there, and to is there, school is there. So that way there is some format in which the sentence are formed. So if we can just make use of this knowledge, then we can easily decrypt the text back to the original one. So this applying knowledge about the language, frequency, the words, combination of the characters to form words, the combination of the words to form sentences and all that. If this knowledge of the grammar knowledge and all that, if it can be used, then the things can be easily found out. So this type of method is what we call heuristic approach. Yeah, though logically speaking, it says that there are 26 factorial combinations possible, and to find that, even the fastest computer may require 9 million years and all that. Yes, computer may require that, but as a human with intelligence can break this, can crack this at a very fast rate, at a very small time this can be cracked, and hence just simple substitution method won't be a better option for that. So we need to look for some better way to solve this. So that's where the olden days the encryption began with simple substitution, then they later realized that it was easy to crack, so they improved that and then went on to the next version, then went on to the next version, and that continued. So that's about how a simple substitution method can be cracked, and the knowledge and intelligence can be made use to crack the cipher easily. Therefore, it is not a best option for encryption. So if you find this topic interesting, if you find this video interesting, so please do like it. Have anything to say, please comment, share with your friends, do subscribe and hit the bell icon so that the coming videos will give you notifications. So that's it for now. Thank you.